Hi, this is Eric Blasick from ENME 351, and today is our Lab 6 with our servo motors. And what we got going on is that we have our power coming out of our Arduino into the breadboard, as well as our ground goes through and feeds our potentiometer. And this green wire right here comes out of the potentiometer and to analog input 1. And over here we have our power and our ground for our servo, and our orange line right here going to our digital PWM 11. So right now the servo is at 80 degrees, and when we turn it and about halfway we see that it's at about 90 degrees, and when we go all the way it goes to 0, and it follows quite smoothly. So right now we're at 0 degrees over here, and when we go up to roughly 90 degrees we see that it's around 512 and at 123 we are at 180 degrees. The way I did that over here is that I matched it up. I found that the duty cycle was 2,500 microseconds to be 80 degrees, 1,500 microseconds to be 90 degrees, and 500 microseconds to be 0 degrees. Over here's our code, and we have our pin set up over here. So our pin 1 is our potentiometer input, and our servo output is our pin 11. And over here I stated again 500 microseconds for 0 degrees, 1500 for 90 degrees, 2500 for 180 degrees, and here set the servo pin as an output. And what we have here for the duty cycle, which we see mine's a little bit different from the one over here. We set the potentiometer times 1.955. The way I did that over here is I matched up these numbers. So when the duty cycle is at 0, it's equal to 500, because the duty cycle is 500 milliseconds or microseconds. And when the duty cycle is at 1023 from our analog read, we set that to the equation 500 plus big X times 1023, which is equal to 2,500, and we go through the equation and get big X. Now we plug that back in. And so how we do this is we tell our Arduino to turn on our servo to go up, and after our duty cycle we turn it back down, and then delay it for 20 milliseconds minus our duty cycle divided by 1,000, because our duty cycle we have in microseconds, so we got to convert it back to milliseconds. We set our potentiometer as our analog read, and we want to get our angle down as 180 times our potentiometer divided by 1023 as a float. Then here we print out our values for the potentiometer, the duty cycle, and the angle of the servo itself.